All right, good day everyone listening, especially the final year panel. I'm about to take you through my project improving source code generation on classified source code archives using structured documentation as a classification base supervised by Owen Grant. I know the project is a mouthful, but hopefully you understand it as we get through. See, my project can be traced back to the dawn of time itself. However, to be very specific on our focus, when we started to focus on development of software, we had many different focuses at the time. One time it was cost, and the other time it was cost and time efficiency. So when we started to focus on cost and time efficiency in the 1990s, software and programming paradigms and programming frameworks were created to for us to be able to generate code faster and have high quality, low cost projects. From the persons that would have focused on the time reduction, uh, a paradigm called the automatic programming paradigm was created. Now, the automatic programming paradigm is relatively new and therefore it can be improved. Generative programming, a type of programming that fits the paradigm mentioned above, was researched by Kieva 2017, where he or she attempted to merge a system of natural language processing for querying and categorizing code. But there was a flaw in this paper. They use code comments to classify the code, and that's where my project is focused on. Because I would have identified that code comments can be ambiguous, documentation itself can be flawed in two ways: that it does not exist or that it's imprecise. So my project is aimed at creating a structured documentation system specifically for the use in code generative approaches. Uh, thus my hypothesis. From the hypothesis, two questions I would have drawn were specifically, will integrating a process of structured documentation on a classification basis result in a valid alternative for classification done using the code comments? And will integrating the documentation process serve as a hindrance to a programmer documenting code? No, because the structured documentation system is a restrictive one, there are some clear hindrances that may be prevalent, and that's why this question is very important. Now, from those questions, the objectives were drawn. The creation of a structured documentation system, which will, one, increase the precision of the NLP approaches, the classification and querying source code, and two, can it and will it support multiple programming languages? And the second one is to evaluate the extent to which the structured documentation system itself is useful in code generation systems. Now, to create this documentation system, because it's a model and it's not just a piece of software, I had to go and get a outline on how you go about doing that. Now, Offerman, Philip, Levin, Olgans, Cornier, Martin, and Bob, Udo in 2009 would have identified in a paper, a process of creating a model using a design science approach. And this is what was followed in this project. Now, you'll be asking yourself, hello, can you guys hear me?
No, I can hear you, Shomari.
Miss, I can hear myself. I can hear somebody speaking.
Just continue. I'm hearing you fine.
Okay, right. So the theoretical model of a documentation system, right, would be the inputs, the outputs, arithmetics, conditionals, and looping. The latter three were considered to be processing, and that is how the system was built, focused on being able to describe the latter three, and less emphasis was placed on the inputs and outputs. Right. So now to test my artifact, I would have had to create some tests. And within the tests, I would have focused on two specific areas. One, a efficacy test, and two, a mental effort and mental load test. Now I'm going to get specific into those when we move forward in the presentation. So My test population was identified to be my peers and programmers known to myself. The test groups now were a randomly selected 20 programmers from that set. Now, the noticeable demographics in the set collected were they were noticeably comprised mostly of self-identified novice programmers with a few advanced to expert programmers. They were identified to their familiarity, their shared familiarity to be in the programming languages of C and Java. And as such, those were the languages tested. Now, they were given 4 tasks, and the 4 tasks governed all of the tests run in this project. The first test was to write a program which calculates the sum and average of a number in of a set of numbers, and you had a choice between C or Java. You had to implement bubble sort in ascending order using C or Java. Write a function which reads a comma separated text string from a file and print it back without the commas. And the last task was to write a program which converts the keys of a map from camel case to snake case. Now, why these specific tasks? Now, these tasks were identified to be from beginner to somewhere between an expert programmer, novice programmer level, and as such was used to test the programmers. So the first test that I would have run was a mental effort evaluation. Now, Krell and Mortiz in 2015 would have shown a seven response questionnaire that was able to measure someone's mental effort and mental load. Now, in the paper, if you were to read it yourself, you would know that they only partially achieved what they were looking for, but because of the small task group, I myself monitoring the testers, and because the 7-prong response gave a large range for expression, it served to be a asset to this project. Now, for the mental effort, the questions are identified in front of you of which the programmers were asked, and this is how they responded when they did not use the generator. Now, the test was split up into 2 phases. And the first phase, you had to use Google or any way necessary to solve the task, and then you only had to use the generator. And this is without the generator. They would have, and most of the group would have identified that the tasks were difficult to them, seeing as the 5 to the totally range. They would have identified that the tasks were difficult to them. They would have identified that the contents of the class, contents of the task were not complicated, but yet they still could not answer the task. They would identify they had taken trouble in answering the task. They tried their best. They tried their best to accomplish the tasks. They made an effort intellectually, which is one of the main focuses of what's to come, that they had to use a lot of their mental power to be able to answer the task. And they have not particularly focused on completing the task, which they would identify they did not, which means they tried their best to accomplish the task. With the generator now, all those results go in the opposing direction. Now, they would have identified that the task now became easier to them. The contents of the task, because they were able to answer it, became a lot easier to them. They did not have any trouble. They made little to no effort because the generator would have given them the responses. They would have made little to no intellectual effort, and they did not completely focus on solving the task because it was already answered for them. Now, the mental load evaluation gives us almost the exact same responses that the programmers were taxed mentally on answering the question. But when the generator was introduced, all those numbers automatically changed also. They now identified they did not try their best to answer the questions because the questions were answered for them. They did not find the task themselves challenging. The tasks were easy to work on. The contents of the task were easy to understand, and the tasks themselves were easy to solve. Now, for the second test, another 10 programmers were used, where one set would have used only where all sorry my bad my where all 10 would have used no assistance to solve the tasks, then they were separated into five groups of five, where another five, where that five one five was tasked with using Google or calling a friend or even asking me for assistance, and the other group were to specifically only use the generator. from from what I collected, I would have identified that the average time in solving the problems would be 1 hour and 30 minutes, give or take 10 minutes. And majority of the programmers, because of their programming level, were not able to accurately achieve all of the tasks given three chances to solve every single task. So if you see, some programmers were able to achieve the task in one try, some were able to answer the task in their third try, and a lot of them failed the task overall. When they were given the generator, not only did I see a large reduction in the time that it took them to solve the problem, but the majority of them were able to answer all of the tasks within their first to second try. The group that was tasked with using Google, calling a friend, or asking me for assistance, most of them were still unable to answer all of the tasks, although the answers were there directly in front of them on Google. What I would have identified in this phase is that although the answers were there in front of them, just copying the code and pasting it into the web browser was not an effective method of programming. That differed from the generator, which gave you an entire documentation system with a step-by-step explanation as to what each part of the code meant. Now, the limitations of my project that I would have identified is that the dataset I use do not represent programmers as a whole. As I said, it was considerably a large sum of novice programmers. And for my project, a simple generator was used. So it does not specifically state that all generators can use this approach, but it does show that there is a possibility, it does exist that the documentation system can be used in a simple approach, and therefore hypothetically can be used in larger, more advanced systems. Specifically for the artifact, the limitations were there is no current way of evaluating the accuracy of all documentation in my system, because anybody could document code anywhere. Even though they were given a template, they could still document the code in any given fashion they want. They could put in wrong information. They can lie, or specifically lie, but yeah. So the second limitation is the system can only document properly written functions. What is meant by this is the definition of a function is a code block that only achieves one task. Now we know there are some programmers that would write code inside of multiple functions inside of a single function. For example, int main. My system cannot document that, and therefore it will not generate the code for it. In conclusion, did I answer my research questions? Simply put, yes, I did answer the research questions, because I can not only generate in C, I can generate in Java, which are two completely different programming paradigms. I would have identified that there is not much of a hindrance to the programmer because they were able to generate the code using the documentation system. I would have accomplished my objectives. The reason for the how much did Corona affect me in being in my conclusion is because the tests were supposed to be run in person, and it took a longer amount of time and effort to run the test over Skype and Zoom. So the results that I would have gotten could be a little bit flawed, because a lot of programmers were given more time to be able to move away from the generator or move away from the problem itself. Was my project difficult? No, my project was not difficult, but it was not supposed to take this direction to begin with, because it was supposed to be tested on Kiva's specific generator. But because Kiva did not give me the generator, I had to use a simpler version just to prove that the project is significant. For future works, I would implement a peer review system to fix the aforementioned problem with the lying of the documentation system and explore another way to classify code. And these are my references. This brings me to the end of my presentation.